Hi, my name is Oktay. Today's video is about lithium. This is a picture of lithium in a paraffin. You have to keep it in paraffin because it reacts with air. Its name comes from the Greek word lithos, which means stone. Atomic number is 3. It's a very soft alkali metal. You can cut it with a knife. It has about half the density of water. The molar mass is just 1/3 of that of sodium. And this number 6.9 gram per mole indicates that there are several lithium isotopes. These are two isotopes of lithium. You have lithium 6, 8%. This isotope is of strategic interest. And 92% lithium 7. Lithium 6 is used for production of tritium. You can hit it with a neutron that gives you helium 4 and tritium. And this is what you can use tritium for. This is the most promising nuclear fusion reaction between tritium and deuterium. It gives you again helium 4 and a neutron with high energy. Obviously the helium 4 isotope is very stable, and the reason for it is it has an even number of neutrons and protons. In Star Trek, they use dilithium crystals. Dilithium really exists. The boiling point of lithium is 1342 degrees Celsius, and the lithium gas contains 99% lithium atoms and 1% Li2. That's dilithium. So dilithium exists, but its molecules, not as crystals. This is an interesting picture. It shows you the nucleosynthesis of all the chemical elements. And lithium is only one of 3 elements that were generated during with the Big Bang event that was 13.8 billion years ago, together with hydrogen and helium. Hydrogen and helium are the most common elements in the universe, but lithium is not as common because there are other nuclear reactions that can destroy lithium, like the lithium burning. Where lithium is hit by a proton, it gives you beryllium 8, which decays into 2 helium 4 isotopes. This is a picture of the abundance of the chemical elements in Earth's crust. Here is lithium. This y-axis is logarithmic. You can see lithium is not in the top 10 of the chemical elements, but it's not a rare element either. And for example, sodium is about 1,000 times more abundant than lithium. But still, there's enough lithium for all of our needs. That's not a problem. Main lithium-producing countries are Australia, China, and the 3 countries of the lithium triangle in South America. That's Argentina, Bolivia, and Chile. This is a picture of the lithium mine in Argentina. Lithium mining is criticized for its high water usage. This criticism is justified. You need 8 to 12 kilogram lithium for 1 electric car. However, lithium still has a much better environmental impact than coal production or oil production or fracking. And another advantage is you have the option of recycling the lithium once your electronic device is at the end of its lifetime. These are the applications for lithium. You can use it for the lithium-ion battery, for ceramics, glass, for lubricating greases, and for pharmaceuticals. This picture shows you the development in the prices of lithium. Just 18 months ago, price was at about 15,000 US dollars per ton. Now it's at 70,000 US dollars per ton. Lithium-ion battery has several advantages, one of which is its high energy density of up to 296 watt-hours per kilogram. It is rechargeable many times, and it has very little loss per month and no memory effect. Disadvantages are it is expensive, temperature sensitive, and the formation of dendrites. This is the worst case scenario for a battery. That's the formation of dendrites. These are metallic microstructures that form on the negative electrode, that's the anode, during the charging process. And if they pierce the separator, They can cause a short circuit, and you get a capacity loss. In the worst case, you get fire. And the way to prevent dendrites is by using interlayer materials. Here's a comparison of today's electric car, that's Tesla Model 3, with the first generation of General Motors EV1 that was produced 26 years ago. EV1, you can see important factors for the electric cars are weight, of course, and aerodynamic. This car had a good aerodynamics. It had first generation had a range of about 113 kilometers with its lead acid battery. The second generation with a nickel metal hydride battery had about twice the range of up to 230 kilometers. And today's Tesla Model 3 has a minimum range of 350 kilometers to up to 560 kilometers, and that's thanks to the lithium-ion battery. This picture shows you the development and the prices of lithium batteries, and you can see that's decline over the years. And there are two driving forces. One is, of course, economies of scale, and second is technological progress. This is a picture of the interior of the Nissan Leaf. You can see the battery pack and its modules. This is a nice picture of, it shows you human ingenuity, right? And this battery is placed at the right place, that is at the floor of the car. And these are the current trends in the lithium-ion battery and electric car technology. But you have one big advantage is a structural battery pack. That's batteries that are directly integrated into the structure of the car. You have no more modules. The 4680 cell is also progress because it gives you a higher energy density. Single piece casting gives you a lighter piece and a better quality piece. For anode material, the element silicon is of interest. It could replace graphite. Another interesting candidate is the element manganese. It could replace cobalt and nickel, which are problematic in mining and also very expensive. And that's why the LMFP battery is a progress from the LFP battery, which is just a lithium iron phosphate battery. And there's a big battery producer in China, that's CATL. They have plans to make hybrid batteries next year. The hybrid battery is 1/3 lithium, 2/3 sodium. Sodium-ion battery has a lower energy density, but it has also advantages, and one of which is higher temperature resistance. And with increasing lithium prices, this hybrid battery becomes more and more interesting. If you want to electrify planes, big airplanes, you need batteries with at least 500 watt-hours per kilogram energy density. This is one candidate. This is a lithium-sulfur battery. However, this battery is not fully developed yet. There are several problems with this battery, one of which is degradation. During the charging and discharging process, you get a big change in volume. And this causes a quick degradation of this battery, and this problem is not solved yet. Another interesting candidate is the lithium air battery. This battery can give you theoretically or practically even about 3 times the energy density of up to 900 watt-hours per kilogram. This would mean if you had this battery today, we could make, with today's battery capacity, we could make 3 times as many electric cars. This is a great example from the city of Shenzhen in China. It has a population of 12.5 million people. They have, in the year 2017, they have electrified the entire city bus fleet with 17,000 electric buses, 79% of which came from the company BYD. And they have also managed to change from gas taxis to electric taxis. And this is a great progress. In terms of costs, in terms of air quality, yeah, and There's again criticism. Some people say you're just moving the problem from the gas engine to the coal power plant. But this criticism is not justified because the coal power plant is known for its high efficiency of up to 35%. That's more than double than the efficiency of the gas car. Another advantage is you can transport electricity over long distances very effectively by transforming it into high voltage electricity. That's why this is a great example, and yeah, this shows you what is possible with this technology. This was today's video about chemical element lithium. My next video will be about another very interesting chemical element, that's silicon. Thank you for watching. Have a nice day. Bye-bye.